Hello and welcome to Demo 8, where we're going to talk about sine and cosine. And that's basically a way to create circular movement. So we can talk about oscillation, which would apply to one of the first things that we did, which is like making a bouncing ball. Instead of it like hitting one, the width and immediately jumping back, it'll have like a more smooth movement. We can talk about pulsing, so making something grow and shrink and look sort of the way that it hits, the end of its growing period and shrinking period. It has that more circular motion and looks like more of a pulse. And then just like circular movement in general, which can create an organic sketch. So if you want to learn more about sine and cosine, you can come to the reference. I'm sure y'all know about the coding train by now, but he describes sine and cosine really well, and there's plenty of spaces on the internet that will give you a more in-depth look from people who have like a coding background, like a computer science background. So the description is calculates the sine of an angle. This function takes into account the current angle mode. Values are returned in the range of -1 to 1. So that's something to keep in mind. And then, so it's written as sine angle. So they're creating a line, and for one of the points, they're using sine. And then they are, with that angle, creating A up here, and they are increasing it at an increment of 2 pi. So, well, divided by 25. So, in our case, we're not going to use the pi. We're going to use radians. So it'll be really similar to what we do with rotate. And so first things first, let's draw a circle. And then I'm going to change the stroke weight to 2, so it's a little bit thicker. Yeah. Cool. So now we can come up top and create the angle. So let angle equal 0. And this is going to have to be transformed into radians so it can work with sine. So down here, I want it to move on the x-axis. So I'll put in sine radians angle. So I'm putting angle inside of the sine function, and I'm changing the angle into radians so it'll work with sine. Cool, so it did move, but it could be not reading it. So now we have to come and move the angle. So technically the angle is moving, but it's moving from the parameters between like -1 and 1. So we just need to like make that larger. So here, the radians angle, like outside of those parentheses, we can put times or even plus 200. So it'll be -1 plus 200. Aha. So it moved the original spot. So we can put times 200 here. So now, nope, it disappeared on us. But now whenever, say it's a -1 transferred to radians times 200, that would be -200. So this multiplying that angle radians is going to make it move in like a larger capacity. So we can put 500 here. And then on the outside, so this is our X for the circle. So if we put plus width divided by 2, it starts in the middle. And so now we can see it go from the left to right, and I'll just press play again. So you can see it starts in the middle now because we did an offset of like half of the canvas. Cool, so if we change this number here, we can create a ball that is moving back and forth and has an oscillation point. So we could also take this number and like make a variable out of it called X speed. And so here up top, I've already created let X speed equal 0 at the beginning. And then we'll come down here and say X speed plus equals 0, or we'll just put 1 for right now. And so it starts out slow and it goes faster and faster. And so we can do if X speed is equal to 500, or is greater than or equal to 500, then X speed equals negative X speed. See if that works. So ideally we want it to go greater distance, and then once it's 500, ooh, I did here if X speed is greater than or equal to width. So it's going to go off the canvas before it flips to negative X speed. So it will like exit the area like we learned in the bouncing video and pop out on the other side at some point. There we go. And then it slows down to 0 and starts over again. Boom, 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 boom. Okay, so if X speed is greater than or equal to width, switch sides of X speed. So yeah, you can do that. So you're speeding, or you're changing the speed of the movement here. So we've got the angle that we are using inside of sine. We've got our X here, which actually I don't think it needs to be equal to 0. I think it just can be let X, and then we're declaring it equal to this right here. And then we've got our X speed, which is placed here, multiplying the angle. So making our scope between -1 and 1 increased. And also this speed, or like this location increase, or like capacity for it to move increase, is being changed. So it's increasing by 1. So it's speeding up, and then once it hits width, it's losing speed. And now let's just duplicate that. That was a way to create an oscillation, but now we're gonna go and we're gonna create a pulse out of that. So I'm gonna change up the sketch so much here that you just wanna like duplicate your previous sketch, because we're still gonna work with what we have here too. So let's move on to the pulse here. So we will change x to width divided by 2. I'm gonna put x equals width divided by 2. And I'll just do y equals height divided by 2 for now, just to make everything, give us more variables in case we want to change it. And then I will create an S for size. Size, oops. Equals 200 for right now. Oh, that's good. Actually, let's make a bigger circle. Cool. So look, we didn't even have to make a variable. God, P5 is so forgiving. In other spaces where you program, it's not going to be that forgiving. You're going to have to put let s up top. Here, since we want it to pulse, we're just going to change that size and see what happens. So we'll change S to sine. Then radians, angle, just like we did before. And we're gonna multiply it by 200 for right now. So we want it to move. And that's pretty glorious and super easy here. Well, that just worked out so much faster than I imagined. So yeah, so the size is, it's decreasing and increasing, and it'll only go up to 200. But if we want to change that to x speed here, it changes and it grows. And so you can play with that, and you can play with the ellipse as well. So here, let's play just a little bit more with the circle and go back to what we had for the X and just watch it move and grow. So that's pretty fun. And change that to, well, let's stop the size real quick. And so here for the Y, we need to come up and also create let Y and let Y speed, just in case we want to change that. And then we'll come down and just do Y speed plus equals 1. And then so we've got, let's just do a constant value here for Y. So nothing's gonna happen because for the Y, we need to put cosine. So here you can imagine that's where all of this information is going. And so in the first parameter, sine needs to be our function. And then the second parameter, cosine needs to be our function. So you can go and look at more tutorials on that describe the trigonometry of all of that. And then here we'll change width to height. It says circle is expecting a number for the third parameter. So I'm just gonna make another S equals 200 for right now. And here we've got two x's, so I just need to, yeah. So now we're seeing the sine and cosine working together, and if we take out this variable x speed and just change it to something constant, then it'll just move in a circle. But you have the control if you want it to change in any way. But yeah, it's really whatever you want to do. So now our x, y is changing, and then here. And so let's just put, since we're using a constant size for this, we'll just do 200 and then get rid of that. And I want to copy and paste, oops, and make it go in a circle, but also to change size. So I'm gonna put my comment back here. So this second circle is going to also change size. Woo! And yeah, if we want to see it a little bit better, we could do no fill function above the second circle. There we go. And then you could put, make it into a for loop as well. So that is pretty cool. So we've looked at oscillation here, we've looked at pulse, we've looked at a little bit of movement. So I want to create another shape, and I'll create an ellipse. And in my ellipse, I'm going to locate it in the middle. So width divided by 2, height divided by 2. And for the size, I'm going to do sine cosine and show y'all what that does a little bit. So we'll start sine, we'll change to radians, and then we'll do angle plus 500, and we'll just see what happens with that. So put sine, radians, angle all in its own little house, and then multiply the angle by 500 and offset the size by 200 and close that. Oof, that looks kind of attractive. It's because I offset it at 200 and the size of the circle is 200, so they're like matching perfectly right now. That looks pretty cool. Could play with that. And you know what? So right now, my ellipse is not moving. If I change, instead of like multiplying by 500 this angle, so instead of adding 200, I multiply by 200. So this is on its width, and its height is 200. So its width is moving back and forth really rapidly, and the speed is because of this multiplying of 500. So if we instead multiply by 2, it'll move a little bit slower. And then, so it sort of like looks like a coin now. If we do cosine, radians, angle, times 2 times 100, because I want to know that it's Woo! Something went wrong. Yeah, oh, it's times 20, not 2. But times 2, and then times 100 needs to be outside a bit. That should work. Yeah. Cool. So if we make it the same number, 200, 200. Sort of is, both the X and Y size are changing. So when you do it with an ellipse, it has a little bit more of like a distorted character, which is fun. If we come up here to the background and we put that background in the setup, ooh, we can see all the lines that it draws, which can be really beautiful. And then if you go and you start to change the color, that'd be nice. So I can't see my ellipse at all, so I'm just going to fill it with C. Cycle through all the colors. So now we can see all 3 of our shapes here. And that's looking pretty cool. And we can add like alpha values so that it doesn't like black out our space too much. So 0.5. And then that has a no fill, but we'll put the stroke at 0.5. So it's black, but it has an alpha value of 0.5 for that second circle, which is just the line. And then here we'll do the same thing for the first circle that we were dealing with. Okay, so now we can see like a little more. There's a little bit more layering going on here. So yeah, that's pretty fun. I mean, you can do like a whole bunch of stuff with this. So it's really, just a tool for y'all to use potentially on the next project, and see what you can make and have fun with it here. But before I finish, I really, really want to teach y'all noise. So I am gonna go ahead and save this sketch. So this is just like a couple different like animations that you could create with sine and cosine. Yeah, that's the one. Okay. I liked this one particularly just because the way that the 2 shapes were interacting with each other. So here you've got function snake, and you've got an XY, so you can change its XY location. I put a no stroke on it, and then so I've got a square and an ellipse, and the square, so this would have been the angle times 5 times 50, and movement. All of my parameters have changing variables here. When the angle or the movement is greater than height, then size equals negative size. So whenever it like gets out of here, it goes back to the beginning. So there are like various ways you could program something like this. I chose to, show y'all this sort of movement. But if you wanted to do something like creating a snake, then you could also do that. Now we're going to talk about how to use noise or Perlin noise instead of the random function. And the reason why we would do this is because noise just creates an organic movement. So similar to sine and cosine, we're just trying to like get better at animating if we want. So for like the next project, using sine, cosine, noise objects will be of great benefit to you if you decide to do the option 2 on the rubric, which I'll talk about. So first things first, let's go to the P5 references and look up noise. Woo! So the description is noise returns the Perlin noise value at specified coordinates. Perlin noise is a random sequence generator producing a more naturally ordered harmonic succession of numbers compared to the random function. So random being like, say we're placing circles at a random location, it's like on the canvas, it's going like all over the place. But noise will like have a random effect on that circle. So we want to change the X, Y, not based off of random, but based off of noise. And instead of jumping from place to place all over the canvas, it grabs a value that's like close to it and moves there. And then it just like sort of like moves in a random way, but like the values are contained to the values like close to it. Noise is, here's the syntax for noise. So X is the X coordinate in noise space, which is written as X off a lot of the times. And Y is a Y coordinate in noise space, optional, written as Y off. And Z is the Z coordinate in noise space, optional, probably written as Z off. Perlin noise value has values between 0 and 1. So sine and cosine has a value between -1 and 1. Perlin noise has a value between 0 and 1. Let's keep working with circles for right now because it just seems to be the easiest. So I just filled it, put a no stroke on that circle, and we are going to create an X similarly to what we did with the sine cosine. And the X is going to equal noise X off. And then because we want our X value to change, we'll do X plus equals 1. So here it's X offset. That can be demonstrated here. Let X off. So actually I'm going to make it look like it does in the example, X off. And then at the top we need to create that variable, let X off equals 0. And then function, if we are looking at the reference, we need to move X off by an increment of anywhere from 0.01 to 1. If we go and increment that variable here anymore, then it'll look more close. It'll more closely resemble the random function. Actually, we may not have to do X plus equals 1. Let's just try to see X off plus equals 0.1 for right now. And then for the X location, we will change it to a variable, multiply that by 200. So it's all like kind of similar to the sine cosine. Like we're creating a variable inside of the noise function, and then we are multiplying it by 200 so that it increases its capacity. So like 1 or 0 to 1 is multiplied by 200. We could also multiply it by width here, and it will just move across like the entire width of the canvas. So if we change this to point, it's still like pretty sporadic. So if we change to 0.01 on that X offset, it's a little bit smoother. Yeah, we could say we wanted it to start in like the middle of the canvas. Just put a parentheses around this noise X off times width, and add an offset of width divided by 2. So it starts in the middle. And then let's go here and make a Y and just copy and paste. And so I've done a bit of research on noise over the years that I've been trying to teach myself how to code. And as an artist, I've been baffled by the math behind all of it and the logic behind all of it. But if you just go and, don't worry too much. I know that's so messed up for me to say. Don't worry about the logic behind it so much. Just know how it functions and know kind of how it works. Since we're like, you're beginners, you're just starting, you're going to be fine. As long as you know that this X off is equal to a number between 0 and 1, you'll be just fine. So, and also it's being scaled up. So we could change this to scale and end up like changing it more. And so like the more variables that you make, the more wild it can kind of, or free it'll look. But back to business, we'll make Y off and multiply it by height. And start it in the middle of height divided by 2. Come up here, let Y off equal 0. And in the circle location, change that to Y. And then we have to move that Y off, plus equals 0.01. So here it's like moving in a diagonal, but we want it to move not on that diagonal line. So when Y off up here, let's set it equal to like 10,000. And then get rid of height divided by 2. Oh. And width divided by 2. And so now the Y offset is just so high here that it's not all starting in the same place as the X off. So since they're, change it back to 0, X off and Y off are the same. So you can imagine this as being 1 and 1. So then that means the width, as it increases, goes to 2, and the height goes to 2, and the width goes to 3, and the height goes to 3. So then you're getting something that's like very linear here. But if we change the y off to 50, you get that offset. It's a little bit more chaotic, and you may want to, because like eventually these are going to sync up and it's going to start going like in a linear way again. I don't know how long that will take, so it'd be interesting to see what that looks like. But that is how you create a random location, but with Perlin noise, which makes it sort of more smooth. So I'm changing the background alpha value to 0.1. And so we've got like a little guy running around. And then if we randomize the size, so let's create let s for random size. And then here we do s equals random between 5 and 200. So if we recall random function, it's got a minimum value and a max. So I want the size to be random between 5 and 200, but then it's going to start changing like crazy. Yeah. So let's go ahead and put that up here. And so every time we press play, the size is going to be different.